What's up?
Alrighty.
So, because I have my editor on this screen at
So,
this
because I have
size.
my editor on this screen.
Oh, I
Okay.
hear myself.
Yes, we're live. Okay. Just was checking the stream there. Let's see. Yep, we are good. Okay, so welcome everyone. We are back on the Ultimate Software Design Live show. And today I'm joined by Florin, and he's gonna help us do some hacking on a new sort of AI project that Bill had some ideas about. Do you want to tell us a little bit more, Florin?
Hey, Kevin. Thanks for having me today. Yeah, so we have this repository called AI Training in under the Ardan Labs organization, and what we have is a bunch of examples that take you from the basics and go all the way through building small prototypes for applications, if you will, showcasing how you can use AI and so on.
Yep.
In the building steps here, like through, for example, example 9, we have a way to read images, tag them, making sure that um, we send them to an LLM, we describe them through an LLM and so on. But Bill's idea was, what if we could do the same with a video, and rather than just taking um, the audio transcription alone, maybe we can get what's on screen as well and feed that to the LLM or to whatever model is running, and get what's on screen, so we have even more context uh, for the application to play with and so on. So what I'm going to start today is basically that, making sure that we can start a chat with an LLM, and then we start adding steps to get a video file in, process it frame by frame, or probably even better, maybe a frame every, let's say, a couple of seconds, maybe more, maybe less, because we don't want to send all the frames to the LLM, and then figure that part out, like what's on screen, get back that, maybe get the audio transcription as well. Not sure how much we'll get to cover today, but I think we'll
Yeah.
make some
And we'll
good
be
progress.
and we'll be working on this through sort of through Thursday. So it'll be cool to see that idea kind of come to life there. I haven't seen much work with sort of LLMs and like image processing, or especially anything with video aside from like audio transcription. So I think this will be super interesting to kind of see how you solve the problem.
Okay, yeah, that's cool. So let's open the repository here. Due to some technical reasons, I will only have my editor opened up for work today, because I'm working on a very wide screen, which doesn't like to be shared. Maybe for the next episode, we can switch to my other computer and work from
Okay.
that one, so you can also see the tabs and so on. But yeah,
Cool,
today
cool.
it's going to be pure code and using Golang for this. So yeah, okay. So let's build first some chat interface to our LLM
Okay.
using Go, and for that we already have some code here in example
I
10, I
think,
think.
yeah, example 10.
Yeah, so under example 10, we have a few different steps here, but maybe I can even should I show you how this works first, and then how and then piggyback on that one, so
Yeah, for sure.
you can see what we are building.
Yeah, yeah, that would be cool.
Okay, let me do some magic behind the scenes here because I will need to connect to Ollama for that. And Ollama is. Should we? Can you share your screen maybe?
I
Do
can
you want to
share
do
my
this
screen.
like back and forth?
Yeah, I could do that.
Uh,
So I can't really get responses because the model we're using is too big for me,
no,
but
no,
I
it's fine.
can.
But for
Okay.
the browser part, I'm interested more like showing like, what's Ollama and how it works and so on until we
Oh, okay.
sort out
Yeah.
my
Yeah, yeah. Let me move some tabs over here. Okay.
my technical issues.
Let's see here. Where am I? I am showing the wrong screen here. Let me move here. Okay. So you wanted to show Ollama.
Yes, maybe.
Uh, Ollama. Okay.
Okay. Yeah. So Ollama, what it is basically a way to run your um, LLMs locally. So you have this concept of models, right, which you can download from the internet and so on, and then you'd need a way to run them. In different environments, you'd have different runners. For Ollama, it's well suited to run this on your local environment, and it can run on pretty much any CPU, GPU combination, and so on. But it also depends on how big the model is. And if you click on the models button up top on the left side,
Yep.
you'll see that they have a list of all these models. And yeah, you can basically say, okay, I want to use the latest and greatest from OpenAI, which is GPT-OSS, right? So you can see under the size column, they have different sizes. And the latest, or the 20B model, better said, are about 14 gigabytes, whereas the GPT-OSS 120B is 65 gigabytes. So, what do those 20B and 120B numbers mean? Those are the billions of parameters that are making the weights of the model.
Okay.
So, the more parameters go into the model, the more knowledgeable, let's say, it will be, the better it will be able to answer a variety of different questions and so on. But the bigger it will become. And in this case, the 20 billion parameters, it's about 14 gigabytes, right? And
Okay.
you see that going to a bigger model will increase the size. Now, there are techniques to reduce those. And what we are looking at, if you click on the 20B model, you'll already see some of those under the model line where it says uh, Arch is GPT-OSS. We can ignore that because that's the model architecture, the parameter number, right? But you also
Okay.
have quantization, and that's one way to control the size of the model. But unfortunately, lowering the quantization, so having something like this MXFP4, also loses a bit of precision. You can overcome that
Oh,
through
okay.
training and making sure that the model responds a bit better even at these lower quantizations, but you need to specifically train for that, which GPT-OSS is. Quantization is basically taking this model from its native format for the parameters, so which is FP32, so floating point 32 bit, and reducing those step by step. You can have FP16, which is float 16 bytes, bits actually. FP8, which is 8 bits, and then FP4, which is 4-bit precision. So
Okay.
the that acts as a way to narrow down the the precision of the model, as I said, but it also helps you compress the model. And
Okay, cool. I
you
didn't
can also
know
do,
you could adjust
go
that
ahead.
um with the model. I
You
thought it was
can,
just essentially the size is the size with the way, they kind of created it.
yeah, you can do that, and you can do some of that on the fly as well. So, for example, you can have one of these production grade services is called the VLLM.
Yeah.
Maybe you can look it up if you want, please. And that VLLM, for example, it has a switch to allow you to on the fly change the quantization of the model. So even if it's, let's say, coming in FP16, you can say, okay, my hardware supports FP8 native, so let's change this to FP8 to gain better speed. Because alongside the size of the model, when you reduce the the quantization from, let's FP32 to FP16 or FP8, you
Mm-hmm.
also gain speed. So the higher
Okay.
the quantization, the slower the speed. The lower the quantization, the better the speed.
Gotcha. Okay.
So
That
it's a
makes sense.
trade-off.
Yeah, that makes sense.
I would generally not recommend going FP below FP8 in mostly in production. In production, I would run with FP16 to be honest. But for local development, for applications which are, let's say, not critical,
Yeah.
you can go something like FP FP8, FP4 without any major issues. You will lose a bit of performance in accuracy, but I think it's a reasonable trade-off to be able to run some of these models locally without having to rely on a third-party vendor to do so. And
Gotcha.
that's why, in
Okay.
fact, if you look at what Ollama does, it's most of the models are coming into this FP4 format because they want to run on as many um, computers as possible.
Got it. Okay. Cool. Very
Right.
cool. Yeah, I didn't know what quantization did, so I definitely learned something there. That's cool.
Yeah, on a high level, it's basically a way to introduce the like how accurate the model is when predicting and so on.
Gotcha. Okay.
Now, um, if you look at this, you also see that it has some other tags as well, like tools and thinking. And if you go back to the models page, you'll see that there are some selectors that you filters for this. You can do embedding, vision, tools, thinking.
Mm-hmm.
Those are model capabilities which allow you to do different tasks. So we won't touch embeddings. I'll just keep it for now. But for vision, those models that are tagged with vision, it means that they accept running um, queries with images attached to them. Basically, they can do image recognition and so on.
Oh, okay.
Um,
Cool.
so
So
we'll
this
use one of
is
these models.
yeah. Okay. Cool. And then
Yeah, you'll also see that some of them are tools. Um,
so this is sort of like going into example 11, where we did those agents with the tools and the MCPs that sort of wrap that the like OSS is a model that supports tools and supports that sort of decision making there on which tool to choose.
yes, yeah. So basically, when you interact with the LLM, you have an opportunity to tell it, "Hey, as a client of this LLM server, I
Yep.
have these tools that are available to me. And during the process of replying, the model can say, use this tool or that tool, and so on. And then for thinking, you have your reasoning capabilities for models, which allow you to basically say, um, oh, I have um, this prompt that was given to me by uh, the user. I can break it down into steps and then also display what the process is informing the response, and then reply to the user question.
Okay.
Thinking
Cool.
models can be really good to help you with more complex tasks, because they have this breaking down of problems and using them taking them one at a time. Um, but the trade-off is that they will be maybe a bit slower than regular models, let's say.
Got it. Okay. So the thinking models are sort of like breaking down the tasks to a more like granular level and then sort of reasoning through it one by one rather.
Hmm. Correct.
Okay. Yeah.
Yeah, and that's why for our examples at least, I would say it's better to use the thinking models that also have tool calling capabilities, because then they reason generally better, and they have that tool discovery part better, so you can interact with them.
Okay.
One thing that I
Cool.
haven't, yeah, sorry, go ahead.
No, no, go ahead, go ahead.
Okay, so one thing that I haven't touched, if you go back to the GPTOSS example, before we go back to the source code and so on. So this gigabytes of models and so on. Uh, if you want to run this locally, there are two options. You either run this on a CPU or on a GPU. On a CPU, the performance won't be that great, even if you have a relatively modern CPU, even uh, if it's a fairly fast one, because CPUs are not particularly good at the kind of tasks that GPUs are, which is matrix multipliers and a bunch of math and so on.
Okay.
And they need to do a lot of operations to be able to produce the result. GPUs, on the other hand, are very good at that, but they generally have rather limited memory. So for example, if you have like I have one of these NVIDIA 4080s or
Mm-hmm.
4090s or the newer ones, you'll have that amount of VRAM capped to, let's say, I have 16 gigs of VRAM. On a 4090, you have like 24, if I remember correctly. On a 5090, I think it's 32, they increased it to something like that.
Okay.
So when you look at this, you would say, okay, this is 14 gigabytes, would barely fit into the memory, but some parts of that may go to the system memory, meaning that
Yeah.
it's not going to give you like the full speed of running the model, as the system would need to offload some of that model into the system memory, which is a lot slower than what you would have on your GPU.
Got it. That makes sense.
Yeah, the big exception would be systems with unified memory architectures, like the Apple M book series. So, like the MacBook Pro, I guess M1, M2, M3, and so on,
Yeah.
which give you access to for your GPU to have access to the full system memory, right? So
Mm,
if you have one of those fancy machines with like, I don't know, let's say 64 gigs of RAM, your GPU could access maybe somewhere around 50 gigabytes of VRAM. So that would suddenly allow you to run much bigger models in memory, or
mm,
offload
gotcha.
a lot less to the system memory.
Gotcha.
And even
Okay.
if you do that there, it's going to be still a fast transfer speed. So
Okay.
if if you want to run some big models, there's like the MacBook Studio. No, sorry, not MacBook Studio. Sorry, Mac Studio with like M3 Ultra, 512
and
gigs.
and there's companies now that are coming out with like home, sort of like home labs, right? Or home like model running purpose built machines, sort of. I've been seeing
Oh
that
yeah,
sort of pop up.
yeah, that's always fun. So yeah, you just have to be careful about your expectations when running these models. For our training, we'll use something a bit smaller for the vision part because we
Okay.
want this to run fast and it's generally good enough. But we also use something like GPTSS to reply. And in fact, if I go here, let me see, example 10 step 4.
Yep. Here we
So,
are.
okay, let's see. I have this. It's gonna take a second. And let's say hello model. It may take a second because I don't think I have the model in loaded in. But hopefully, it shouldn't be a problem.
Let's see. For me, I did this on the last stream running the example 11 and I just about blew up the whole live stream at my computer with the software running too.
Yeah, so see that's one of the disadvantages of having a rather limited VRAM
Yeah.
in your
Yeah.
system and also like system memory. So okay, now let's see if it works a bit faster if I do this again. So hello model. There you go.
Okay.
Tiny
And
bit
that's
faster after it finishes loading.
gotcha. Okay. And that's sort of like a warm up, right? That's what they call warm
Yeah.
up? Yeah. Okay.
Well, it's not only warm up, but I think I also had like a different model loaded into Ollama. So it needed to
Oh,
offload that first, then read from disk the new one, and after that it does need to do either some warm up or in case of VLLM a lot of warm up. But then yeah, you get to have much better speed.
okay.
Uh,
Cool.
and now we can say what tools do you have access to?
Tools available. Yeah.
So see now the model we have here in red thinks about the question, right? And it reasons and says we need to figure out which tools are available, and the only one that I know of is this get weather, and it nicely gave us a markdown output of the tooling it has and so on. So if I were to say what's the weather in I don't know, NYC, yes, uh, we need to go. Well, see, live demos, it won't load. But if I say what's the weather in New York, huh, it will
There
still
we
not
go.
work.
Oh, no. They just gave a different.
Yeah, we would need to debug this a bit to understand why it's not calling in. I am
The
running the
and this was step
RC5.
this was step
This was step 4. We can try step
4.
5. Let's see. Maybe I did something. I'm running the latest Ollama build, which is 011 RC5. So they did some changes there. If needed, I may need to revert to a previous build. Whether in oh, there you go.
Access to real-time
So
data. Okay.
oh, because this one doesn't have access. Oh, right. Tools do you have access to? Uh-huh. Okay,
Yeah,
so
this
see,
one. Okay. Yeah.
example 5, we don't have that tool registered. However, we do have some other nice tools. So we can say, give me a list of all Go files in the current project.
Yeah.
And
There we go.
there you go. All right, so this is tool
Very cool.
calling in action. And you can see it after our question. It spent a bit of time before it started processing our query, and then it said, "Oh, okay, I have access to these tool search files, and um, I should probably filter for .go files because I said all the Go files, right? So it knows that when I say Go
Gotcha.
files, those are .go extension files." And it will default the path because I haven't said any path, but I did say current project, right?
Got it. Yeah. So it's essentially like when a user asks a question, the first step it does is try to match it to a tool before giving any kind of response, essentially.
Yes, if available, it could try to do that.
Got it. Okay.
And now it said, "Oh, okay, so let's do a tool search because for files, right? Because that's the tool call that we need." And we replied back with a bunch of file paths. That's
Yep.
good because our function does that. And if we are to take the function name from here, we can actually, I know you can't see me jumping actually, but there you go. We have this
To search files. Yep.
register tool search file, right? And through the magic of registering this and making it available to the LLM, it knows based on the description that it can read the contents or search for files or do anything like that, right?
Cool. Yeah. And I actually on the last episode I played with this a little bit and added a tool. Never pushed the code, but I did just for learning purposes add a tool to the MCP server that would hit like a joke generating API and it would just give me programming jokes.
Nice. Okay, right. So we kind of use the part of our tokens, right? Which is another thing that you'll see on that Ollama page. If you remember, we saw a column saying the 128K tokens.
Yeah, the context.
That is the context window, right? But you have to remember that we have the total context, the max size is 128, but for reasoning models, we can also spend some of those tokens on the reason part. So
Oh, okay.
this reason is not for free. Let's say it's within the context of your context size window, and
Got it.
in
Okay.
total we have just about 2,500 tokens, out of which 36 are reason tokens.
Got it. Okay.
Um, yeah, you can think about tokens as me being maybe around three quarters of a word.
Yeah. Okay.
So maybe plus minus. This depends a lot of many factors. I won't go in. But you see this in action. You see that we can talk to an LLM and so on. So maybe let's get some of this code from here because you already have it. Let me move this to the first part of the screen so we can work on it. And let's make this into our, actually, I should probably make a document here, into our vision model calling,
Yeah.
running on video and so on, right? So step one, rip off some of the example code that we have in step five,
Okay.
right? So I know we have a convention here about um, packages and so on. These
Mm-hmm.
examples show you how what do we want to do, how we can process a video first, right?
Yeah. I guess step one in this step one is the plan to get like a basic chat loop set up. Um.
mm, Chat loop, or do you, let's go with the video first, because chat loop
Okay.
we can do
Yeah.
later. So the way I would approach it is, let's have a proof of concept of a video being processed, and then once we have that up and running, we can then um, send it to the LLM in step two, and then step
Okay.
three we can integrate this into like a chat
Got it. Okay. Yeah.
feature.
Yeah. I like
What
that
do you
plan.
think?
Okay.
Okay, so step one, we how to extract frames from a video, and that's it. We'll just extract them.
Cool.
Okay, we don't need any other. Okay, let's take this and build step two, just to have it here, because then we'll forget our plan. Builds on step one, example 12, and to process the extracted frames using an LLM. I think that would be good. Would be
Cool.
good. We should probably add back the Ollama up at this point. And then on step three, we want actually on and example, and shows you how to search for a specific frame using an LLM
Okay.
and vector database. We'll get there. Okay, so I think these would be good enough to start with. So there are many ways to handle this feature extraction. We probably need some really short videos.
Uh, which I can probably get you a video.
Okay. Yeah, I'm not sure if we have any of Bill's uh, training videos available that we could.
I do. I do.
Ah, nice, nice.
I do.
So yeah, we can build on that, and let me focus on this other part then.
Yep.
Meanwhile, so how do we want to handle this? I'm sure there's a variety of ways to do it in Go as well, but um, I'd rather not spend the time searching for a specific package right now.
Okay.
There's this thing called FFmpeg, if you've heard of it before,
FFmpeg. Okay.
and what it does is basically is the go-to recording, conversion, streaming audio video tool for the
Okay.
world, if I can say so. It supports a bunch of things like out of the command that it offers, among which is conversion, which is good, reading a bunch of files, good, so we don't need to worry about the input format and whatever particular options were used to produce it. But from what I know, it also allows you to extract frames while processing it. So we won't need to worry about any of that.
Okay. Cool.
So let's try to do that. I haven't tried it before, but it's been on my to-do list for a while now. Let me see if I have it installed yet. FFmpeg version. Nice. Okay, so my version, I would say it's fairly old at this point compared to what you can download um, of the website, but should be good enough for uh, what we need right now, I would say.
Version.
Yeah, it's like 7 dot something,
Okay.
and that's because I'm on a rather old version of Pop OS. So yeah, let's see if it works like this, and if not, I'm sure we can debug it together.
Okay.
So the first things first would be, um, let's execute a command from Go, and let's shell out to get the FFmpeg version,
Okay.
right?
Yeah, and this is you're doing this on a different terminal. Oh, okay. There you
No, no, no. I wasn't. I was just stepping back and forth here because I wanted to make sure that I'm getting the
Yeah, yeah.
correct uh,
No
stuff
worries.
first. Okay, so in Go we have this exec package which allows us to say something like exec command and then ffmpeg. Okay, the editor wants me to do something, but I'd rather have something else for now. I think it's dash version, but let me check if dash version works. Okay, so it looks a bit nicer now, right? As an
Yeah,
output,
okay.
we can get this just to make it work. It's good enough, let's say. Okay,
How
so
how long do you need the video to be? Could it be like a couple seconds?
I mean, to test it, under a minute, anything is fine.
Under a minute? Okay.
10 second, 10 seconds, even less, because we can. So if it's a short video, like a 5 second one, we can extract a frame every, let's say, every second.
Okay, cool. So I'll just give it.
Okay. Wow. Let's make this a bit nicer and not panic. So extract this as a run function. And let's take some of the boilerplate from here. We can say run function here, error, and then we say while running FFmpeg. Okay, and then we have terminal. Wonder why this is. I should probably also run it.
Okay.
Okay, so let's start small. Let's make sure that our stuff works. Rather than doing that, let's say print f out, and then we say string out. Okay, let's add example 11, example 12. Step 1. I'm sure if Bill is watching, he's screaming right now. Florian, you forgot about.
He's he actually messaged me saying under example 11 there's a tool that can execute any shell command.
Hmm, interesting. We could probably play with that in a later example.
Yeah, sounds good. Sounds good.
Okay, cool. So we have this running. It's up. It's running now. Now that we know how to do that, there's this magical command which we can use um, to extract the frames. Let's
Okay.
test it out. Do you happen to have that video file?
I'm
By
sending it to you right now. It is sending
is
through
is it on Slack
Slack.
or
Yeah. I might need to make it a
okay?
bit smaller though.
Okay, fine. Let's move this then to. Ooh,
Oh,
not
but
located.
oh, sorry. I
Which
sent the
file
wrong
variable?
one.
It's fine. It's fine. Don't worry. So, FFmpeg version for now, and then let's see if error. So let's start with running FFmpeg version first, and then let's say process video, right? And then we can say maybe return from this an error. What we can do here is now return nil, and let's build on the previous example. Command. It's almost like it's reading my mind. See, not much different than what I want to do. Output, right? And we actually want this command here. So let's do that. Let's call it video. I'll put it under. Let's create a new directory in here. Videos, just in case. Let me download the file as well. I hope
Yeah,
this
the
happens.
1 second. There we go. The short one. There. It's 26 seconds.
Okay, I'll have to trust you on that one. Okay, cool. Okay, so it's downloading. It will be ready in time.
uh
Let's take
yeah, that's the
that
big one
here.
that I sent by accident.
Oh,
Yeah, I
okay.
sent another one. USDL live test is the name.
Mm, that's what I tried to download. Huh?
Interesting.
So you removed that one? Okay. Well,
Yeah, I removed one. I had canceled the send, but it
I
still
see.
went through.
Oh, Slack. Okay, fine.
There we go. Yeah.
There we go. It felt a bit faster to download. That's true.
Yeah, the
Okay.
other one was
Cool.
big.
So videos. Let's see USDL. Let me put it this way. And then it's probably under samples. Let let's see. CMD samples. Cool. and we want the output to be hopefully under the same uh, path. So cmd, let me create a directory here because I don't want to pollute this. We can probably upload the mp4, but I mean, we don't want to upload all the frames and so on. Frames, video frames, let's say frame
Mhm.
cmd samples videos frames, and we can probably keep it like this. So with this command now almost there, we should be able to extract our frames and dump them into the
Mm.
directory,
And
right?
this is all thanks to FFmpeg that kind of does this
Yes.
work already.
Yes, well, that's the plan at least.
The plan, yeah.
But yes, basically what we would say is take this file and for every second take a frame, output it, and be done with it. And let's say out error. Let's handle the error again,
Yep.
and let's print fmt printf. Magic. So when we run this again, while running FFmpeg status 1, I would like to know more about it, please.
Yes.
Okay, well, let's debug this. So let's try to run the command without any of the editor magic stuff. Let's
Okay.
see if the command is fine. I've never tested this, but that's why we are here. So in case this works, then it's probably some escape around the parameters or
Maybe.
something like that. There you go. Do we have the frames? No, we do not. Yes, we do.
Oh, yes, we do. Very
Yes, we
cool.
do.
Oh,
There you
awesome.
go. So how many frames do we have? 1 to 27. You said it's about 28 seconds long or something like that,
Yeah.
right? Not much changes in here. We can actually do some other cool tricks. So in FFmpeg, we, we said we extract one frame every second, but we can extract every other second or every 5 seconds.
Yeah.
Um, let's go with every 5 seconds. Let's test this first. And to do that, it would be FPS like this.
1 5. Okay. Yeah.
So every 5 seconds, we change this. Not much changes on the screen, unfortunately,
No, I gave
but you
a
can see probably
bad example.
the cursor.
Yeah.
Ah, it's fine. We can find a different one, maybe for Thursday.
Yep.
For now, it's good enough because it does have some text here that we can look into and so on. But it's exactly what we need, right?
Very cool.
So
Okay. Interesting.
let's debug this, right? Just a small command and most of our heavy lifting is done. What I suspect happens is we have a bug somewhere in passing the parameters here, specifically maybe this one,
Hmm.
which will
Okay.
be interesting to debug.
And what is it that that command did? The VF?
So the VF, it's basically telling you to extract the frames at a rate of how
Oh,
many
okay.
every. So it's a video filter.
Okay. Got it.
That's where it stands from. So I don't know. Let's see how we could do it in Go, right? So It's probably somewhere around the parameters. What do you think? Should we split these up?
Maybe.
Or we can try. So there's another way to execute this, right? We can try this command. And you can't see me copy pasting, but I am.
Yep.
What we can do is we can do something like this. We can do a call to the bash or
Okay.
to shell, even better. So we can do bin shell. We can tell it -c, and then we can have the FFmpeg command here, and we say FFmpeg command, and we do this. And
Um,
yes,
Here, I'm gonna send you a command, and essentially this command is going to pull keyframes. Um, is gonna
okay,
pull
we can
keyframes
pull.
from the video.
Let me make this work first, and we can switch
Yeah,
to pulling
for
the
sure.
keyframes alone. So one problem with pulling keyframes is that you don't exactly know when they happen, and it can vary based on the video itself. So you don't
Okay.
have any control over when that
Be
keyframe happened. Have you missed anything, or
okay, and that's because a
we go?
keyframe is
I don't
essentially
know.
when
I
something
don't know if
changes.
that was clear enough, but if I go here, say clear example, it run, and we extracted this. Let's see what happens if we run this command as well. Why not? Let's explore. So keyframes, you say. There you go. And what do I need to do? Input. So for the video filter, I would need to change some parameters like this. So now instead of video filter FPS one every fifth second, we have place whatever select is.
Take
I'm
your
gonna guess
time.
this is the keyframe representation. Let's see how many of these do we extract now. And if I go here, there you go. So we
Okay.
have 14 of these, roughly every couple of seconds.
So basically that is only it's only going to have an image if something changes within it. Is that how the keyframe works?
That's a good question. Let's ask the LLM. Make example 10, step 5. What is a keyframe in a video? See, it is doing some thinking now. Probably
Mhm.
it's loading the model again.
Yeah,
It,
I'm sure.
Ollama will unload the model if it's not used after a certain amount of time. So,
Got it. Okay. It's a frame in a video that is
okay,
independently of other frames.
or iframe. Yeah. So, from what I understand, keyframes are basically a way to have like checkpoints in the video,
Okay.
and they are the full picture rather than the motion vectors and updates between what changes on the screen between one frame to another. And
Okay.
that's how they are used, right? And it improves the efficiency in compression and those errors. If you've ever entered like a TV stream or live stream where you've saw those blocky pictures and so on, that's
Yeah.
because you are in the middle of the stream when the receiver hasn't got an iframe yet, and it's
Mm.
trying to display you something, but it doesn't fully understand this because it has no reference. And whenever the next keyframe comes in, it's gonna say, "Oh, okay, so I need to display this full picture," and then the next frame picks up and says, "Change this on screen," and so on.
Oh,
Right?
okay. Very cool. Okay.
So basically, that's it with less words than what the LLM said. But yeah, you can control this, and based on it, you can have higher or lower compression, and so on and so forth. For us, I guess it's good enough. Every couple of seconds is actually pretty decent. You, um, okay, so let's keep the processing of the video. Let me add this to our ignore stuff because now we have one more thing to handle,
Yep.
right? So if I am copy the reference right now, and I don't want anything from it to be included in my Git history. How big is that file that you've sent me? 7 megabytes. I do feel that we should probably not commit this particular one and try to find a
Yeah.
bit of a different example
Okay.
just to showcase the LLM better and the feature and so on. So for now, I would say let's not commit this,
I
and then
agree.
we can find a better one and update it for next time.
Let's see.
So let's just say this for now, and then we go back and we add this. Okay, so I think we now know how to extract frames. Should we build more on top of this? Should we send it into the LLM now? Because
Yeah.
when you look at it, it feels a bit less than what you'd
Yeah. I
expect,
mean,
right? Especially if
honestly,
we
I'm surprised how sort of simple that was. I mean, thanks to kind of FFmpeg there.
yes, it does require you to have FFmpeg, but that's a small price to pay, right?
Yeah, for sure.
Okay, cool. So let's make it a bit more interactive then. Let's take this and somewhere in example 4, if I remember correctly, sorry, example 9, step 4, I think we actually have a way to send this to the LLM
Okay.
and understand what's in there. Let me see if I get the image. We've updated this back and forth quite a bit, so hey,
Vector index. Okay, I see some
yeah,
vector.
okay. So we have this read of the image, right? We want that. Actually, I can go straight to step 5 because we have a way to get all the files from the directory. And let's move it here. We have a process video, get files from directory, which fits in lovely, right?
Yeah.
Our output will be in JPEG. We can change it to be whatever. And then let's say read the image. We do need to do that for each individual image. And let's figure out how to connect all the puzzle pieces together. So, step 1, we've made this work. Cancel the context. We have a chat and an embed model. Let's just use um, chat for now. We'll get to the embeddings in the next in the next example.
Okay.
Okay, we skip all the database stuff because we don't want to have to do that for this. Save images into the database. I think we need to go back one example here where we question response, search result. Let's see, where do we send the LLM the model to the LLM?
Mm,
So I haven't mentioned this. We'll use the Qwen 2.5 VL model. So let's see.
okay.
There you go. Example one. Easiest, right? So constant prompt. Let's take all of this.
And the Quen model, that is a chat model.
Yes, so that would be the chat model as we call it, but it also, if you look at the Ollama version
Hmm.
of the page, it will tell you that it supports images, which is good for us, right? We do
Okay.
want images
Yeah.
to be supported. Let's take only the first image there, so we don't have to worry about anything for now. Let's change this to LLM chat. Chat with completions. Let's say read image. Let's keep this easy for now. We'll only use one image, and then we'll go and run the whole directory.
Okay.
So we have img. Where is the code path here? Image path. Right. Okay, results. And then we take the results and we just display them for now. I think that's good enough. Let's do this. Let's keep a bit of video processing again because I want to make sure that we have all the bits and pieces working. So const.
Europe. Okay.
Okay. So this would be my Ollama link. This would be my model. This one is a fairly small one, but we can make sure that. Let me actually make sure that I have it installed so we don't have to get an error that it's not installed there. I know you can't see it, but
There's behind the
that's
scenes magic right now happening.
oh yes. Unfortunately, I'll
Um,
switch to a different screen. We do have it installed. That's fine. Okay, so URL chat and model chat. URL chat model. Remember, we want this to also have like a way to search for them and so on. So that's going to be step two, my
Gotcha.
friend.
Okay. And I do have a sort of a question from Bill here. Um, it would be interesting to compare two images to see how similar they are. We can filter down the keyframes.
That is a very smart idea. Let's do that as well before inserting them into the database. Before images are inserted in the DB. Obviously, we changed the steps and what they do. Check if they are similar.
So we can do that. We can compare the two images and sort
Yes.
of filter it down that way. Okay.
Yeah. And we'll do some magic thanks to that embeddings type model that I skipped in the beginning because I kind of wanted to get here to the point where we get to run it. Let's see. So, example 12, step 1. If I clear the screen so you can see it nicer, this may take a bit longer because we don't have all that chat interface, but we can add
Mm,
that
okay.
shortly. And there you go. we get back some description from it. It says macOS,
Study.
Visual Studio Code, Excalibur,
Yeah,
and a
which
bunch of other
is what
things.
he's using. Okay. Oh, very cool.
Ardan
CPU
Labs
bound,
logo,
IO bound.
right? So frame one, Ardan Labs
Ardan Labs.
logo.
Oh, that's awesome.
Yeah, so only in a few lines of code. Now
That is awesome.
let's let's make it more interesting, and instead of prompting you to describe the image, let's change the prompt a bit. New prompt, and let's say give me all the text in the image. Um, I don't know. Let's just try that. Let's see how it works.
Okay.
So part of using these LLMs is also a bit of magic creating the prompt, right? And making
Yeah.
sure that you find the right thing. Should work a bit faster now.
Let's see. Boom, boom, boom.
Appears a screenshot of okay, and see 200 nanos, 1K. I think it's getting there.
Okay.
Let's see what's in the frame. 1000 nanos, 200 nanos,
200 and then 200 now.
240
Oh, okay.
inserts,
Yeah.
1000 nanos. See, context switch, core, context switch, CPU bound, IO bound.
It's actually doing a good job. Oh,
Yeah. Let's say do not describe the image, right? Because we see here the image
it's trying to
contains the
assume where it's
description.
from. Yeah.
Yeah. I'll put the text in a JSON format. This text found in this image. If no text is found, we can say error, no text found. Good enough. My editor thinks it can do
The editor
this.
thinks it does. That's fine.
Yeah,
Okay.
and there you
Text and
go.
then
Text.
nano. Boom, boom. Awesome. Okay. That's cool.
Yeah, we can.
I love seeing sort of like the prompt engineering kind of like how it changes and makes it into something sort of powerful.
Right?
It really
Because
makes all the difference.
we just went from, having a description and so on to having JSON output by the model.
Exactly. Like I find that super fascinating with all the LLM work.
Um, or markdown surrounding the JSON out. Because I'm not really sure if we do this or if it's done through by the LLM. See, there's like this JSON and
Okay.
so
Yeah.
on. And let's see what happens now when we do that. There you go.
Yeah. Okay.
Press enter to add text. Wow. Hey, it works.
No, it does.
Woohoo.
I'm super impressed with this right now. It's very cool.
Yeah, it does seem to omit what's on the left side on the editor. So
Yeah.
do not describe the image. Make sure that all the text is in the image. Make sure that you include any text editor, I don't know, ID tool too. I don't know, something like this. I think we can
Yeah.
probably refine it a bit later. So now, hopefully, now it still doesn't want to do it, but I think it's good
No.
enough.
I
I
wonder
wonder why it
why.
doesn't.
Yeah.
Yeah, I think it's focusing on this too much, and
Maybe.
then it's like, yeah, I shouldn't. Um, if there's an ID on screen, include that too. Last attempt to
Let's
force it.
see.
Talk.txt Scalidro
It,
service.
it it did get something, I think.
Yes, I don't know
Service
why
and talk.
where it got that font family and so on, but I mean, okay, let's remove this
Interesting.
and we can play around with the example prompt later. Okay, right. So we have this, and we said still that we should probably process all the stuff, right? So let's change it a bit. And now that we know that we validated everything here, we can start doing this. Let's first extract the video frames. If they're not nil, okay, we process the video. I think we can get rid of the old prompt, and let me format this a bit better. We can now read one image. Like, let's go back to example. I forget which one it is, but one of these examples that does have a bunch of init database get files from directories. So let's handle all of this. It's step 5. Let's close these other two, and let's start cranking get files from directory. Perfect. And now for each file, we want to do some processing to it, right? We want to describe it.
Okay. Image file.
Now, let's say image path doesn't need to be updated here. Results are here. In the interest of time, I would like to not have to run all of them, but let's let's still do that. I can stop it later. So,
Okay.
processing
Process.
step frame 1. It's gonna take a second. Let me close this as well while we are waiting. Remember, we need to do all of that code to load the image and so on. But funny enough, it doesn't want to do it. Oh, have we?
Process image.
So we already run the processing step. That was fast. But let's add some debug information. FMT
Okay.
processing video. Finished processing video. Right? Let's see what happens. There you go. The model was just not loaded, probably.
Got it. Oh, very cool.
Okay.
And now it's going through one by one
Yeah.
and doing it. Awesome.
Uh,
Text. Oh,
so we can probably move this into processing the video stuff just to have a bit more structure. Processing video, print line, and then defer. Done processing video. Okay, so now it's all self-contained and we know how to do this.
awesome. That's cool.
Oh, we know that the command won't output anything, so let's just run it and not have all the output. There. Processing video. Done. Okay, cool. So we have everything that we need. I think we can call step one a success for now.
Awesome. And
Should
I
be
have
should
a
be enough.
better example for you. One that shows a video that shows some code being written.
Oh, that's nice. Do send it away, please, and I'll include it.
Yes. Let's do
Okay,
that.
so now that we've done all of this, let's just copy paste everything here, right? And let's start chipping away at the problem. So the suggestion was that we should do a test of how similar the images are, right? Before we commit them to the
Yeah.
database and so on.
Comparing sort of like keyframes.
Yeah. Okay. So that would mean we would need to read two images and then based on the differences and so on, move to the next one. Now, there's two ways to do it. We can always read the current one and the next one and then advance the pointer by one, or we can do a difference between current one and then move to the next one that's different enough.
Mm.
I would, I don't know. Let's pick one and then we can improve it
Yeah.
later.
I would say the first option, I feel like makes the most immediate sense.
Yeah, and we can build on that if needed.
Exactly.
Okay. So, what do we have here? We have a way to contact the LLM. We have a way to recognize what's in the image. And now what we can do is we can go back to step three, I want to say. Yes. And take the embeddings.
Okay.
Okay, so what are these embeddings? Think of embeddings as a way to describe an input, be it an
Mm-hmm.
image or a bunch of text and so on, from an LLM without having to specify those features that your description relies on. So, for example, for us humans, you have that if I say horse, you know it's an animal, it has four legs, a
Yeah.
certain shape, and so on. When you do embeddings and you send them horse, it will return you back a vector of features, but you won't know which are those features and you won't know those values either.
Got it.
So for the LLM, it would be something like a vector of, let's say, float values. I'm going to
Mm-hmm.
go float 32, and it's going to be something like 0.1, 0.121, whatever, minus
Yeah.
1
And
dot.
that
So,
also changes based on like the parameters of the model, right? Like whether it being a 20B or a 120B.
no, so those are different. If you go back to the Ollama page for models, maybe we can show that up as
Okay.
well.
So let me
I,
bring that up.
I think we can talk a bit on that one.
Whoop, there we are.
Okay, so if you go to models, you'll see there's a flag for selecting all of these. And you say embedding at the top left on the page. And you see that these embedding models are much smaller, like 300 million parameters, 500 million parameters, and so on. They are
Okay.
much smaller because they are trained a bit differently, and the purpose for them is to return these features alone. They are not meant to generate any text, and in fact cannot really be used for that.
Got it. Okay. So they don't do any natural language sort of
No,
processing. Okay.
no. Their purpose is just to get this input and then get it back out and give you the features of that input. Now you selected a very good model, this BGM3,
Hmm.
which allows you to do like multi-language granularity and so on. Some models offer that, some models do not, and so on. It's up to your implementation to require it.
Got it.
I like using this one, but yeah, there may be better models. You'd need to test this. But you see that it has a smaller context window, so it's only like 8,000 tokens, and it will return, in our case, a vector of 1,024 different features always, and
Okay.
that's it. There's no relation between the context window and the size of the returned features. So you'll
Got it.
have to discover this by reading the documentation or the config of the model.
Got it. Okay.
Okay,
Interesting.
yeah,
That's
they
really
are
cool.
totally different purpose. Whereas, let's say the LLM that we're using now, Quen 2.5 VL,
Yeah.
besides vision, it can do text and you can chat with it and ask it questions and so on, like we do for the other model for GPT OSS. They can't do embeddings. So you could force
Um,
them, but it's unadvisable.
yeah, it's not
They're
what it's
not good at
designed
that.
for. Exactly.
Exactly. So let's take this piece of code, which neatly fits into here, and let's say now we don't want this client LLM embeddings, or let's keep it embed because the other URLs are the same. So
Consistency.
exactly, and let me take this. Okay, both URLs, both models, everything looks good. Just a few more steps in here. LLM embed, and then let's output just a part of it because
Yeah.
it's not much value adding that. You'll see on first we output the results and then we add the vector as well
Okay.
as an output.
And it's
Uh,
embedding the results, essentially, is what we're creating the embedding for.
yes, it's embedding the results because we want to extract first what's in the picture and so on. Only the
Okay.
relevant parts, the text and so on. If we wouldn't do that, if your image is static enough, you'd
Mm-hmm.
run into a trouble where because we also want to do similarity search, it's going to say, oh, well, 90% of the image hasn't changed, so it's going to give you a high score
Oh,
always.
okay. I see.
But it also means that um, when we do the filtering, you don't get good values.
Got it.
Let
Okay.
me get status. So you said that there's a new good test video that I can
Yeah.
use.
Yeah, that one is just showing a code sort of window. Um, Bill is writing some code there from the service class.
Nice. Okay. So let's switch that in example one. Let's run with that and then
And that one is 1 minute long, so a little bit longer.
a bit longer, but should be fine for our example. Because I would like to make sure that we commit this before going to step two.
Okay.
So as you can see, extracting the frames, not a problem.
Run terminal window help. See, now in that one, it's picking up the uh, sort of top of the window there.
Yeah. For whatever reason, it decided that's relevant. We can improve the prompt and we can make sure
Yeah,
that
yeah, that's all.
we tweak it and make sure that we only extract, for example, what's in the code editor rather than the surrounding frame of the editor.
Exactly.
But I think it's doing a pretty good job. So if I
I
would go
think so
to
too.
description of frame 3, it would say, okay, wonder what's in frame 4. Here it decided not to find any text. We should play around with the prompt a bit, but
Yeah.
not right now, I would say. Okay, so let me reverse the git ignore. How big is this one? Ooh, 40 megabytes. Tough call to include this or not.
What do you normally like? What do you consider, let's say, a clear line when something's large enough not to include it
That's a
in
good
Git?
question. So you may notice that we have some pictures here that are like under 100 kilobytes each, which
Hmm.
I think is reasonable. But whenever you get to megabytes of including the data, that starts to get a bit blurry.
Got it. Okay.
Now, we could probably lower the quality of the video, or we could lower the we can decrease the amount of time
Got it. Yeah.
we have.
Which I can do that. I can do that before the next show to make it a little bit
Okay,
better.
so I'm gonna name this training MP4, so not committed still,
Hmm.
but it's gonna allow us to do to commit the video first and so on, and hopefully give it a nice path training. We do have some examples here in Zarf, which, for example, chunks is about 500 kilobytes book as well as a reference. So those are, towards the upper limit, I would say, usually.
Got
But
it.
in our
Okay.
case, we do want to have available the video always for everybody wanting to clone this.
Makes
So
sense.
we'll make an exception. Okay, so status, let's see. We only want to add staged copy. And then step 3 as well. And then git ignore, make file. In make file, I think we are adding only step 1. And then this one should be good to go as well. Wrong terminal commands. Okay, so 12. Video processing. Okay, let's continue with our journey. Let's
Cool.
add example 12 step 2, and let's see how this runs now. 12 step 2. Processing video, that's because we still keep the old name here, training, and my editor doesn't want to do that. Let's see. So we now have the frames. It's going to take a second. So now what's going to happen is Ollama will bounce between models.
Okay.
And depending on your settings, it could load them at the same time, or it could need to load the first model that we need, the vision model, process the image, and then unload it, load the embeddings model, process that, and so on. So we may need to change a bit how this works, but also keep in mind that it will affect the costs as well.
Got it.
Uh, if you are in a real life production environment,
Mm-hmm.
right?
Got it. Okay. No, very cool.
Yeah. So this is
Is
taking way longer than I would like. Let me see what's happening behind the scenes. So
behind
the
the scenes
Quantum VL,
magic.
yes, behind the scenes magic, indeed. Quantum.5 VL is already loaded, so I'm not really sure why it's complaining here and doesn't work, as we've only added this new piece here, which we haven't gotten to yet.
Embed. Could it be the size of the video?
No, because I mean FFmpeg is really
Oh,
efficient.
done.
That's
Done
why I like
processing.
it. Right? It's done processing. I think it's Ollama on my machine that would need probably a restart. Let me
Got it. Okay.
do some of that magic behind the scenes. It will take a second now to come back, but this time around it should have dedicated access to only that model.
Let's see.
I mean, the image is here.
Interesting how it's.
Hmm, let's see. Let's try again to run it. If not, we'll maybe skip all the description of the image for now. But we
Okay.
cannot really do that, can we?
Uh,
See, that's the problem.
so this is essentially Ollama getting stuck, is what's happening.
I mean, not sure if getting stuck, but something is up for sure. And it doesn't like replying. Let's give it a bit more time. Maybe it needs a second to catch up.
Interesting. Okay.
Well, keep in mind I'm running this on my computer, so performance may vary.
Under.
Huh.
Mm,
I think we may be stuck.
interesting. It and is there any way to add sort of more logging to it during that step?
No, not really, because we are the step that Ollama basically has to deal with it. See? Refreshing it a couple of times just
Okay.
made it work. And look how fast we've got the embeddings. So I don't know if you've noticed, but it's basically instant, right?
Yeah. Okay.
Because that model is so much smaller and it just runs. And what it took is it's taken this and vectorized it as such. Now we can even go one step ahead and take this from a JSON, decode it, and then feed that to the LLM. And we should probably
Okay.
do that,
And that's how we'll get
right?
sort of our like user friendly description, sort of.
Sort of, yeah. So let's see if we can do that. And we can say resource error. Let's unmarshal, JSON unmarshal, right? And now we have these results, and then I think Bill is using something like an example from MongoDB, if I remember correctly, in one of his client D
Client D. Oh,
things.
okay. Yeah. The
Yeah,
document.
this one. So let's make it here. Let's make this, convert it, and we can say if. Not really sure we should return. We can just skip it for now,
Okay.
right? We can just say, hey, look, there's been an error. Uh, we'll skip it.
Okay.
I think it's a better user interaction, at least for our use case.
Unprocessing.
Yeah, sadly, that's the part that we'll have to fight with. Unmarshalling invalid character. So we may still need to strip those coming
Oh,
in. Results. Um, Trim. Right. And we have results again, which should hopefully fix the problem. Let's see. If not, we may need to print the document. Oh, right. And it's also saying that it's starting with JSON, right? Even though we instructed
um,
it not to, if I remember correctly. Let's see. LLM response. And then let's say, processed response,
okay.
right? Because we need to understand what's going on. If I
Yeah.
remember correctly,
What is what is going in and coming out?
so it can take a few seconds. I will just skip ahead because that's what I remember that we would probably need as prefix JSON. We can say, oh, not trim the prefix JSON. We could just say, let's ignore, was there anything else in here? Oh,
It's
right. We can't run that. So it
okay.
was 0 to JSON. That's what? 3, I think 4, because I think it was JSON like this with a colon. If not, it's gonna
Mm,
skip it anyway. So let's see.
mm, we have
Okay, so it's
backticks.
JSON and a
JSON.
new line.
Got it. Yeah.
Huh. Okay. JSON and a new line.
And I thought the prompt we were using, we got it to sort of omit that part.
Yes.
Won- I wonder if maybe that would be a bit easier.
Do not include else, but no. We can yell at the yellow one.
In all caps. Do you think typing in all caps to it like that makes a difference?
Yes, in depending on the training and how the model was um, constructed, yes, it will make a difference, and we can see it here.
Okay. I've always wondered that. I think it's nice for readability too, like when you put like do not in all caps or all in all caps. But I've always wondered if it actually makes a difference or just feels that way.
But but then again, in the same application, different prompts and so on,
Hmm.
um, it also decided to still continue doing that. Right, so
Yeah,
we still need to probably format it. But the first one was great. Follow up ones, mixed bag. So we can definitely work more on the prompt side for sure.
definitely. It's interesting how it just doesn't, it's not consistent.
Uh, yeah, I wonder if we just move this to the beginning. Um, Make sure that the JSON is valid. I forgot to tell it that. So you've noticed maybe that in certain places is like invalid characters. So because
Okay,
we have this right,
got it. Okay.
and it just forgot how to valid JSON.
Processing
The good part
video.
about us, go ahead.
No, no, I was just reading. Sorry.
Okay, so the good part about FFmpeg is that, as you can see, it always will override your frames.
Oh, okay. Yeah, it's not just continuously adding hundreds of frames.
Yes.
Yeah.
Oh yeah. Now that could be bad as well, and I think one function that we can add probably is here to empty the directory before running the examples.
Okay. So sort of like a cleanup or just make sure it's empty when running. Okay.
Yes. Yeah. I wonder if we already have some similar cleanup before any of the commands, or we should do it in Go. We do have something similar here, so I'll just steal this. And let's make this a bit nicer, because that way we can actually see it happening, right? We
Yeah.
get to play with it a bit better. Cool. So Did, has it finished? Nope.
No. It's super interesting how it just gets stuck in some instances, and then in other times it's like super fast,
Yep.
super temperamental.
And I think we probably just want to clean what's inside that directory. It also could be my hardware and so on. I'm curious if on Thursday we'll encounter the same issues when I'll change computers around.
Hmm. Okay. There's
There are the frames, there's the description. Still looking for a JSON here,
hmm.
right? So this is part of the prompt engineering that we would need to solve.
Yeah, that's part of it. Like maybe like make sure the JSON's valid for direct unmarshalling or something.
In a valid JSON format. Okay, encode. So clearly this didn't have any effect on this. Code any.
And the JSON output.
I guess we can try to do that,
Yeah.
right? So encoding any special characters and so on.
And that's like where a lot of sort of like the prompt can kind of make or break your app in a way when you're working with AI.
Yes, yeah. So it's not only the prompt, but it's also the model. It's
Mm-hmm.
also the quantization of the model. So
Yeah.
I think I'm running this in the. So I'm running what? It's the Quen 2.5 latest. If you go to Quen 2.5 latest page, um, I think it's running the 7 billion parameter model with Q4 as quantization. So remember when we said in the beginning, the fewer the parameters, less experience, so to speak, it has to reply
Mm-hmm.
to your questions. That's part of it.
Got it.
And
Okay.
because this is not a JSON, like a thinking model either, it won't be able to, let's say, catch itself during that processing phase that it does,
Oh, okay.
right?
Yeah, I see
So
where that's
that's
coming in now. Okay.
exactly. So that's why in some cases those thinking models would be good, but you would need to find a model that can both do the thinking and the vision, or thinking,
Mm,
vision, and tool calling, and that would fit in your constraints as well for the hardware.
got it. Okay. Yeah, and
Okay,
there
so I'm
is
marshalling
no.
with invalid character JSON. Okay, so we are getting somewhere. Let's see. What else are we missing here? So we are removing the parts from the beginning. Oh, sorry. I should have noticed that. We want to start from character number 4 and move all the
Oh,
way to.
yes.
You know what? I was trying to unmarshal only the JSON stuff. Wait, that's wrong because the error was way too consistent. So yeah, my mistake on there on that one.
Okay. And now Is that also going to remove the backticks at the end?
Yes. Yep. So because we use the trim function,
Mm-hmm.
I know you can probably see the documentation if I just pop it up, but it is a leading and trailing Unicode
Oh, okay. Leading and trailing.
code
Got it.
points. Yeah. So might just as well run trim once.
Let's see.
I wonder if I hit some sort of a bug in Ollama because I'm canceling the request.
Huh. That's
So maybe here we should have like a sleep
okay.
that allows me to control something like maybe a 2 second sleep so I can stop between images. And you know what? We can do something even better here. So um, LLM embed, instead of doing that, what the editor suggested, we can say embed. Oh, we can only embed the text. We can't embed image, can we? Why can't we embed the image? Mm, okay, well, we tried. We should probably extend this to embed the image as well and figure out how this is done, because then we could compare what's in the image with what's in the document,
Oh, okay.
right?
Yeah.
Sadly, this one is taking way too long.
It's fighting back, Florin. It's fighting back.
Yeah, as I said, I'm curious if on my other computer we would have the same problem.
Is the other computer is it a Mac or
Yeah, that's a Mac
Oh, okay.
and has much newer GPU and so on,
Got it. Okay.
and a lot more memory. But anyway, here's the right. We now have the process response correctly. It's always formatting,
Uh,
except this part. We really need to figure how this
yeah.
JSON is. And look, if you look at the example from the LLM,
Mm-hmm.
so at that point, I think we are better off just not decoding the JSON for now until we can improve the system prompt,
Okay.
right?
Okay.
Because I mean, we would spend probably the whole time on this one, and we are almost close to the hour anyway.
Oh, yes, we are.
So let's do this. The LLM response stays the same. We do away with all of this. Oh, I should probably still keep the LLM response in here. We tried, but that's part of the fun, right?
Yeah.
So now we have these embeddings, and what we could do is we could save them to the database, right? And let's see
Mm-hmm.
if we have enough time to finish on this one today. Let's go and copy a bit more from example 5 this time around. Under example, sorry, step 4, example 5. So we would have this document notion that we need to introduce now.
Okay.
And basically, it's what we'll store in the database,
Got it.
right? And if you look at it, It's the file name, description, and embeddings. So everything that we already have. And this document is used like this here. And there's a tiny step that we need to take away as well with that sleep. So it's all good for now.
Hmm.
Okay. Inserting frame information,
Okay.
right? We can take the file name here and let's see what's missing. It's missing the call and so on. Let's take all of this. We will need to format this a bit better to match the style, the previous style. Okay. I think it's taking shape.
Yep.
And let's see init database. So let's init the database as well. Tell me.
I like I like in this IDE that you can sort of collapse the functions sort of for readability.
Oh
Like
yeah,
in VS Code, or well, I'm using Cursor now. I At least I've never done it, but it's really nice
I'm
how
sh-
Goland is giving that to you.
I'm sure you can do it, and um, probably there should be an option, or hopefully they are working on one.
Yeah, I'm sure there's like an extension for it, or if it's not something off the box. But now I've never
Okay,
really thought about it until seeing it now in action.
yeah, I customized a bit the ID, but most of it is out of the box usage. Okay, so we now have the init database. We can insert one. What happens in init is we connect to the database,
Hmm.
run the collection, and create the collection, create the vector, make sure that we have the paths correctly, set up, and so on.
Okay.
We would need to say compose up. Starts the Mongo service because we would need to run that as well. So behind the scenes, so to speak, I can say make compose up. Oh,
Open. Okay.
yes, we can ignore that for now. So OpenWebUI is like a chat interface
Yeah.
that would
Hmm.
serve as a web UI and so on. Fortunately, it seems that I did not have it um, pulled
And
in Visual
we're
Studio.
we're using that in this project
No, for this particular one, I'm not sure. No, for this particular example, we definitely don't use it.
no, yeah, in this example, no. I was just wondering if it was in the Oop,
Oh, I think that's an alarm. They're
that is
getting
an
close
alarm.
to.
That is an alarm. But it's okay, we can finish the thought here.
Yeah, I think like, it's super close to us being able to dump this to the database, and then Thursday we can optimize on that search.
For sure.
Or while we wait, we can optimize on that search because we mostly have all of that already. So you'd be able to also see if you processed that file already or not. And we can say, okay, find the resource. Let's skip everything that we dump into the database. Mm, config DB. See,
Permission.
this is a Linux problem.
Oh, okay.
Key file. if I say RMRF zarf, give me a second. This is behind the scenes magic, but I can show it to you as well. So RMRF zarf docker db data and then sudo, and we can do the same for OpenWebUI and SQL data. Let me compose down just in case.
Oh. Oh, I think oh, you're back. There we are.
Oh, it could be from the compose down command.
Yeah. Yeah.
Anyways, so cannot remove permission denied. Let's see. There is something that doesn't agree with itself here. I wonder if it's already running. So it's still trying to run the old stuff. That's fine. Thankfully, that was a quick command to run. Uh, Let me clean up quickly, and let's try once more. Sudo database, because apparently that's the only one that we want to remove. We still have a
Huh.
huh, exactly. I wonder if I'm running any other data. Oh, we haven't seen
Huh.
anything. Nothing to see here.
Don't mind me.
Right. So, of course, we need to sudo yet again.
There we go.
Now,
Oh.
now it should hopefully. I don't know. OpenWeb UI seems to be happy to start, but okay, we will
Longos.
leave this as an exercise for next week. For
Yeah.
next time, not next week. Unfortunately, I don't want to hold you too much over time.
No worries. Yeah,
This is
we can mess with
unfortunate. Or wait, one more trick up my sleeve.
that.
Mode 077 sarf docker db. Behind the scenes, I'm running a big chmod. There we go. It's
Oh, there
working.
we go.
Yes, nice. Okay, so if I unclean this and move this here, we just lost that um, thing, but that's fine. It's still running in background. Thank you, editor. So let's see it one last time running. Clear step 2, and you know what else we can do? Really nice. So they just introduced this way of connecting your editor by
Okay.
just clicking on that. I know you can't see it, but I'm
Oh,
setting
yeah.
up the.
No, I can't.
Yeah, it's a pop-up window, unfortunately.
Okay.
But what we can now do is we have a way to explore the database visually, which I
Oh,
like a lot more.
yes.
Now, now, if the LLM would work,
That would be nice.
but hey, we've seen it not working a few times. Um,
It's a feature, not a bug.
yeah. let's see, do we insert everything into the database correctly? Embed text, file name. Yeah. Would you look at that? We've used all the correct names. So it's just the LLM configuring this. Come on. There we go.
Oh, there we go.
First
Okay.
first thing, let's end on a positive note. And there it is. It's
Very
in the
cool. Okay.
database, and we have everything that we need: the file name, we have the embedding, we have the JSON description. We are all set for next time to do some filtering on similarity, so we only include the files that are interesting for us.
Awesome. Very cool. Very
Cool.
cool. Let us move here.
Yeah.
Awesome.
Stop sharing.
I think that was a awesome episode. It was really cool to see that, and then the FFmpeg, seeing how that works. That was a new piece of tech for me. So I think that was
Cool.
pretty cool to see. I learned a lot.
Awesome. See you next time.
Alrighty. See you, everybody.